Thank you so much, James, for inviting me to this. My name is John. I've been a data scientist for, officially for 11, 12 years now. Unofficially since I was about 4, and I started organising my Lego by colour, and then size and colour, and then number of bits that had fallen off. I was quite a violent child. But anyway, the kind of stuff I've always been interested in is really around the power and the value of data, and why it's important that you actually understand what's going on, not just with the data that you're using, but the application that's going into. And this is going to be touched on in elements of this talk. But before I get into that, yeah, thank you so much for inviting me. And I'm really happy to be in another city away from Manchester, because I think Manchester sees itself as like, yeah, we're the tech leads of the north. Nah, that's debatable. And saying that as a Mancunian as well hurts my heart, but still, the kind of like innovation scene in Sheffield's fantastic, and I'm always happy to come over, even if it is a particularly painful drive. That's all good. So yeah, I've got a few areas to touch on. A little bit of a demo, a little bit of a kind of some thoughts about why projects fail, and some of the stuff I've done on how you can mitigate that. But there'll be kind of a segment at the end where anyone has any questions, more than happy to ask them. And if you've got any questions as we're talking, feel free to just shout, stick your hand up, throw something at me, preferably not a glass, something soft would be ideal. But there we go. I'll just put up this quote from McCarthy, and I won't read the quote out, but I think it's quite a good summary of what AI is and why it's becoming such a big thing now, that technology has become an integral part of our lives. AI, machine learning, computers, robotics have always kind of been present in human consciousness. And what I mean by that, here's a very brief history of AI in 3 images, which is always appropriate, I feel. The idea of AI, as in a synthetic device replicating a human task, goes back to the days of Greek myth. So this is an image of Talos, which was a guardian on the island of Crete. I've got a Greek colleague. Whenever I get that wrong, I said Minos last time, and he chewed me out afterwards. But it was a protector of the island of Crete that was eventually defeated by Jason and the Argonauts. That was kind of one of the initial forays into like non-human entity doing a human task, in this case protecting an island. It was eventually defeated by draining it of all its internal goo, which will also affect a human as well. But in this case, it was around the kind of artificial aspect of it. And it kind of remained in the aspirational part of mythology, some applications in technology, but really it's when computers started becoming a thing that AI really kicked into gear. The ability to replicate tasks and behaviours really started kicking off once computerization became a thing. And that's really revolutionised everything. The end image there is a self-driving car, obviously a bit of a representation, not necessarily one that's actually going to be driving down the M62, but still that's probably going to be a large application of AI in the future. And then you get into the sort of fuzzy area of how do you deal with the ethics of it. You can program your car to be an altruist, or you can program it to be an egoist, that kind of thing. So that becomes now quite an interesting thing to grapple with. We've got the years of technology, years of coding stuff, so we've got loads of technical expertise, but now we have to go back to almost the start again and say, well, how do we deal with the ethics of it? There's no real answer to that at the minute. So that's going to be something that's going to become explorable in the next few years. So I've got here first and foremost a demo. So I've referred to AI a few times in this, but what actually is AI? Because you hear about it all the time, you hear the term artificial intelligence, but what fundamentally is it? I've got here a very small example, and this is with code, so bear with me, anyone who's not interested in code. Probably going to hate this bit, but hopefully you won't. What I've got here is a very short piece of code that takes a training data set. In this case, it is War and Peace, and analyzes it to get the statistics out. So it analyzes essentially every single pair of letters in this text and logs how often they occur together. So it takes this and go, right, that's a Y and an E there, the next one an E and an A, next one an A and an R, and it builds up a categorization of how often letter pairs occur together. And you might think, well, what good is that going to do anything? Well, the idea is that this actually codifies the English language. So it codifies how often statistically it's likely that two letters appear together. I would imagine once it's kind of analysed this, it'll determine that, okay, T and H appear together a lot more than a Q and a J. So therefore, that is a good data point to start building up from. What this piece of code does, and I will share this with James, who can share it with everyone. So I've got a GitHub repo where you can have a look at this, play about with it. That's all good. What this does, in a very few lines of code, don't worry, I'm not going to take you through all this. That would be insufferable. But I've got here a text sample that I'm going to jumble all the letters up and then produce a uncoded version of it. So here it is. So here's the actual encrypted text. It's just taken the sample that I've got, substituted letters at random, and then the statistics that this is built up, this sample's built up, is going to attempt to decode it. Now, I'm going to scroll down and you're going to start to see it decode. If anyone can shout out what it is, I'll be very impressed. So it starts to encode it, iterates it, basically 10,000 times, and then does that over and over again. So you get tens of thousands of simulations to produce what is a statistically likely English passage. Obviously, in this example, this is only work in English, and if you want to do it in French, you need a French text or whatever. And now it's starting to become maybe a little bit more understandable. I'll just zoom in a little bit. And eventually you get to a decrypted text, and it runs that over and over and over and over again, comes up with the most statistically likely sample that is representative of the English language based on the sample it's read. So the overall summary is this. Anyone? What's this? David Bowie, get in. So this is Life on Mars. I always use this because it's the best song ever. But essentially it's jumbled all the letters up and then used just statistics around the English language to actually figure out what the most likely outcome is. A couple of problems with it. One is letters like Z, Q, J, it's going to get that wrong sometimes because they don't appear as often as other letters. Also, if you have quite a short passage, if you just have the word hello, it's probably going to get that wrong because there's not enough there to test whether it's accurate or not. But it highlights to me the fundamental drive of AI and machine learning is it's all based on statistics, and sometimes it can go wrong. And that's two of the things that ultimately can lead to AI projects failing. So I'll come back to the presentation. I'll just refresh it because I think some of the images didn't load last time. So let's do that. There we go. And get back to this one. By the way, anyone who has got a keen eye, you might notice that the background and font is SpongeBob. So again, that's just a nice thing to have. So this tends to be the life cycle of an AI or a machine learning project, right? So most of the times it starts off with hype. That is either hype from people who want to engage with these technologies. So, ChatGPT is a thing, let's use that. And everyone just piles on. And then you get into the valley of, oh, hang on, we don't quite understand this enough to be able to properly get any value out of it. And that happens quite quickly. So when it comes to actually turning the kind of idea about something that you want to do with machine learning or AI, when you want to turn that into something that's tangible and realizable for your business, for your research project, whatever, you start off with an idea and quickly you realize, okay, either the data quality is not good enough, we don't have the infrastructure to support it, or there's some other reason why there needs to be more kind of effort and building up of the techniques or the technologies that actually would facilitate your project. So it starts off with a big, let's get loads of money, let's get loads of time invested into it. And more often than not, it turns into, hang on, the scope was maybe not quite what we thought it was going to be, or maybe there's some fundamental element of technology missing, or quite frankly, the data is just a bit crap. That's one of the most fundamental things that shuts down an AI project. And people who sponsor these stuff, so senior leadership, people who are funding you to do it, they don't like to hear that. They don't like to hear the data is not good enough, or we don't have the skills around to do this, or we need some form of governance around it, especially after there was all this hype built up and everything like that. So often then the project either fails and you get kind of the people who have got a bad taste in their mouth. So they go, well, AI, no, we're not going to invest in that again for a while because the last time it failed. Or the kind of yawning face. It becomes somewhat analogous to what you thought it was going to be, with a bunch of caveats around it. So it wasn't quite living up to the hype that was set out in the first place. And then it becomes, well, it was all right, but the project didn't really turn into what we thought it was going to be. So this is kind of broadly why AI projects fail. There's going to be massive exceptions to this, of course, but from talking to most of my colleagues and people in similar roles to myself, this tends to be what is reflected when it comes to looking back on projects that haven't gone as well. The ones that do go as well, however, is about flattening it, essentially. So when people get hyped at the start, any product owner, any data scientist, anyone involved architecturally or on the engineering side kind of needs to be playing down the hype. Like, okay, that's great that you're excited about it, let's leverage that. But at the same time, we need to think about some of the boring stuff, like data quality, data governance, data ethics, and that leads on to then working on a cohesive level throughout the business to actually understand the full end-to-end life cycle of the problem that you're trying to solve. So essentially, it's playing down the hype, doing a bunch of work and research to show how valuable that the opportunity could be with the right guardrails in place, and then eventually that turns into shed loads of money and time saved and everything. That's the dream. But the important bit is to keep feeding that back in to the start. So keep talking about the work that you're doing, why it's important, show that to people, as opposed to trying to go away, build something, and then come back saying, look at what I built. And then everyone's going to kind of go, oh, yes, no, not really what we thought or wanted, so yeah, try again. And often that's a problem of communication rather than anyone doing anything wrong technically. But I think for me, it's all about making sure that things are fed back to senior stakeholders, to the team, just to not only get a sense check on what the actual value that is tempted to be delivered is, but also how this might evolve in the future. So you get more money, more data scientists out of the process in the end, and you get more kind of goodwill around the work that you've been doing as well. So I'm going to send a bunch of links to James. Where's he gone? Over there. There he is. Hello. So everyone can have access to the slides, to some other resources, to the GitHub repos and stuff. And I'm always more than happy to chat to people about anything that you'd like to.